All right, we are back for the daily Leetcode challenge. Make this full screen. Looks like this. Range product queries of powers. Hope everybody's doing well. 10th to the 5th, already looking at this, already cheating a little bit. Not cheating, but just checking a peek of this. 10th to the 5th. Okay, so given a positive integer n, there exists a zero index array called powers, composed of the minimum number of powers of 2. We're sticking to this powers idea. Okay. We've had powers the last 2 days. So compose the minimum number of powers of 2 that's summed to n. The array is sorted in non-decreasing order. There's only one way to form the array. You are given an array queries, left, right. Each represents, we define product of all powers. Or left. Oh my gosh. Okay. A lot of BS. Okay. Return the array of answers equal to the length of queries where answers of I is the ith query since the okay. Let's look at the sample because sometimes these things get really confusing. Okay, so 0, 1, 2, 2, 0, 3. What does n go up to? 10 to the 9. Okay. For n to 15 powers 1, 2, 4, 8, it can be shown that powers cannot be smaller. Small side. What is n? Okay, I'm a little confused. Answer the first query. Powers of 0, powers of 1. 1 times 2. Powers of 0 is 1. Okay, so this is I'm slightly confused about what it's saying here, so we gotta evaluate this a little more. So I'm kind of seeing they have 0, 1, and 1 and 2. Each query represents a query right to find the product of all powers with left. Okay, what is n? Let's figure this out. Given a posit, there exists a zero index array called powers composed of the minimum number of powers of 2 that sum to n. Okay, so this, yeah. Okay, this is like the powers array. Oh, I see why n. Okay, this is so. Okay, perfect. So really 10 to the ninth. Okay, so the len of powers is never going to be greater than 30 because log 10 to the ninth is 30. Okay, so essentially what we're doing here is we're finding the query ranges and multiplying them. Now what's interesting is that what is queries? Len? 10 to the fifth. Can we brute force this? I think we can brute force this. Right? I believe we can brute force this, where essentially what we could do is have it such that for each query, since n is the len of powers is only going to be 30 values, we could just take that and then multiply them all together. I think it's going to be a bit slow, but I'm just thinking about there's a better way you could do this where you save the queries, but you'd have to remember you'd have to like remember kind of like the segments. I mean, you could like search for like no, it'd be a pain in the heck. It would be pain. So I think this might work. Okay. Um, I guess let's compute powers, I guess. And that's gonna be simply I call the sum so far, I guess. And so essentially it would be just like keeping track of how sum so far has to be less than n. Um, less than equal to, I think actually. Yeah. Um no, it's less than actually, because if it's less than equal to, we'll do an extra one, which is not what we want to do, even though it doesn't really matter. Um we also need like a we need like an index, which is gonna keep track of powers. So we start at 2 to the 1. We're skipping 1, it looks like. Uh, so 2 to the index, and then x plus equals 1. This will be sum so far. Actually, we'll be smart about this and put this into a helper. Okay, so I think that should generate the powers. I feel like, yeah, we'll find out if this is going to time out or not. Can you do mul? Is that a thing? I always forget. Is it not mul? Because like if you do sum, it yeah. Is that not a thing? It's like product. Um, prod or like yeah. Essentially, it's we won't cheat, but let's just say we won't look at like we'll look at that in a minute. Um, R plus one. Like we won't look at a solution online if that's a thing. We'll just do it like this, just pretending like we're bare bonings in the airport or the airplane. Um, powers, and then this will be powers of I, or whoops. Wait, it's gotta be in. Okay. I think that's kind of it. So we're just like kind of going through each query and then adding it to res. I feel confident about this. always something so small I mess up on. Why are we getting so many? Okay, wait. Oh, wait, wrong position. Wait a minute. Our powers are wrong here. In this case, powers are 1, 2, 4, 8. Powers is 2 here. Interesting. If you had 14, is that even possible? Wait, this is wrong. Because you have 32. Wait, this is wrong here. How can we create it's a greedy solution? Sorry, this is wrong actually. Um you have to find the first smallest power of 2. Like if it's 32, for example, right? The best way to do it is to find the bottom one, which is 16. Right? Because it's 4 and 4. Then 5 and 5 is 20. No, you do 25. But the minimum number of sums of 32 would actually be 16 and 16. Would it not? Instead of it like being and there's only one way to form the array? Wait, what does that mean? Does that mean that they all have to be unique? Because if you have 32, right, you could do 25. Then you have 7 left, which would give you. So if you have 7, you could do 1 maybe, and 4, which is 5. You could do 2. Yeah. How do you find the next smallest one? Like 33, for example. How would you get that? I don't think that's possible. Or would it be two ones? Let's actually make a test case here. So the test case we're doing is if we have 33 and then we have queries 0 to 1. What do we get? Just comment that out for now. Oh my gosh. Comment that out too. Expects 32. 2 to the 6th. Wait, 2 to the. I'm being dumb. Wait. I'm being dumb. I'm thinking about. Wait, 2 to the. I'm thinking about it backwards. That's my fault. Okay. I think 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. Right? No, 2 to the sixth is 34. Or, well, sorry, no. It would be 2 to the fifth. To get to 34, you need to do 2 to the fifth plus 2 to the 1. So I think you want to keep finding the biggest value. Okay. Let's make this a little bit better. Okay, while n is greater than 0, I think. Cur. So how do you find? Okay, we can guess we can do the math here. Okay, so n equals 2 to the x, right? Um, and so we know n's a constant. So essentially what we do here is we log n. Um, and then this becomes 2 log x. And so or no, it'll be x log 2. Yeah. So it's going to be, and then we would divide log 2, and log 2 of 2 is 1, so we can essentially cross it out, and essentially it would be log n of x. Okay, so then here we would do curve is going to equal log of n, and then we're probably going to want to take the floor of that. Okay, and then n minus equals square. And then powers dot append. Let me see what else we got here. So then, what do we do next? What is index? I don't think it's necessary anymore. And then also some so far I don't think is necessary. So we just had a little bit of a hiccup there. Uh, yeah, we're infinite looping here. It's fine. Okay. So math.log of 15 is what? Let's see. Print math.log of n, or yeah, n will work. Let's just see what that is really quick, and then we'll go from there. It's 2.7. Um, Wait, do we want to take the ceiling actually? I want to take the seal. I don't even know why, but and then this is gonna be 2 to the cur. Okay, just gonna just YOLO submit here or YOLO pass out with that. I want to print powers. Let's see what we're getting here. See if we're getting the right power. So we should get 1, 2, 4, 8 for um. Oh, we forgot to do this. Okay. Well, all right. Let's see what we got here. 22 minutes. That's fine. So we got 8, 4, and then 4. Ugh. I don't like that. Should be, I like the floor more, I feel like. But that's gonna be wrong too. Here we go, 4, 2, 2, 1. Oh my gosh, I'm dumb. It's gotta be 2. Yeah, okay. We're base 10. We gotta do base 2. Okay, and I was like, I like the floor much better. Yeah, there we go. Perfect. Okay, we got that. Delete this. Now let's add back our original solution here with the second part. And then, okay, we're getting this right and this right. Now we're getting 32, right? Because we're doing it backwards. Powers has to be reversed. An easy way to do that? Or do we want to just do it like this? We could just L minus 1, I think. All right, we'll just reverse it because we don't want to have to switch. Really? That didn't fix it? Really? 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 Wait, what? I'm a little confused here. We're starting at R. No, no, no. We want to, yeah, we want to start at, I okay, for clarity, I get it. Yeah, we want to like minus it by like Whatever. It's gonna be a pain. We're just gonna power it up. Powers dot reverse. Is that right? I don't even know if it's powers dot reverse. Yeah, it was powers dot reverse. All right, yellow cement. Look at that. One answer was wrong. I think that has to do with the fact that hmm, back to this goddamn floor thing. What's up here? Are we getting encycled in there? No. Oh, wait. Well, cur is greater than zero. Wait, we had to fix this. Okay. All right, we'll do. The, it's not exactly right. Oh, it's not divided by two. I'm thinking about it wrong. Is there is log the best solution? I I don't know if there's a better way to do this, and I'm actually gonna GPT this because I'm not sure. Is there a better way to get the logs? I mean, I'm gonna cheat here. Ah, we could do the bitwise. Yeah, okay. And then shift it, shift it. Okay, let's analyze this, but this is definitely the best way to do it. I think at that point it was kind of just an understanding, so I feel confident. Like I didn't feel bad about cheating per se. Largest power of two less than or equal to n. So the bit length is like what? What is bit length? I don't even know. What is dot bit length? It gives you the position of the highest set bit. Okay, so like the 10th position and then minus one. Why the minus one? Bit length minus one is essentially doing floor. Okay. So if you have 5, the bit length is 3. Right, because it goes over by 1. Uh, yeah, okay. And then if we submit this, passing all test cases there. And I still have this wrong. Interesting. Are we missing something there? Missing a Z? No, that's wrong. I'm actually. Oh my gosh, wait. Oh my gosh, that's my fault. 10 to 9th. Mod. Oh god. Okay, we have the mod 10 to 9th here. Yeah. We had the solution earlier. We forgot the mod. Okay. Oh my gosh, we're still wrong, but so close. Oh, it's not 10 to 9th. It's 10 to 9th plus 7. Okay. Beautiful. All right. We learned a little trick. Bit length -1 is flooring. Math.log. Appreciate everyone watching. We learned a little bit. We learned a lot, and I feel confident about the solution. Could have came up with faster, but it is what it is. We're moving and we're improving fast. I think we're getting better though. See you tomorrow.